Okay. All right. So today's topic is more recursion. And really the big thing to know about the difference between today's session and yesterday's section is in yesterday's session when we talked about recursion, we defined it as as doing a particular operation multiple times. And one of the kind of key tenets of the problem we saw from yesterday was every problem we did yesterday with recursion, we could have also done it with a for loop, right? None of it was kind of recursion specific, and that was because for every problem that we did, we actually did know how many times we had to do a certain operation, right? So if I was asked you to go through every character in a given string, we could do it with recursion to say, keep going until you reach the end of the string. But a for loop also gives us that luxury as well, right? A for loop can also say, hey, start here and stop when you reach the end of the string. And so because of that, it may have seemed like we were trying to kind of make you do something or make it a lot more difficult than it had to be. And the main reason for that is because today we're going to talk about a second category or second class of problems that can only be solved with recursion. And these are problems in which we actually don't know how many times we have to do something before we start doing it. And so therefore recursion becomes kind of our only and best tool to use in this scenario. Okay. Okay. So so in this case, we have something that should look pretty familiar from yesterday, which is if I give you an array, I want you to log it out for me, and you'll notice here all this function is doing is on line 1 we take in an array, on line 2 is we go through every element in the array and we console log it out. On line 8 you'll notice how if I was to feed in an array with not only numbers but also nested arrays, well then the answer kind of is not what we expect it to be, right? We log out 1 as the first element, and then for the second element we log out the array 2 comma 3. But what if I actually want us to go through and log out every single number within the array, regardless of whether or not it's nested? So if I was to update the function from the last page, right? Lines 1 through 3 are identical still, except now between lines 5 through 10, rather than just blindly logging out the element, we actually on line 5 we do a check to see if, hey, is the element in the array an array or not, right? That's why we use the array.isArray. If array.isArray and we feed in the element, if that returns true, and remember in the if statement, whatever is in between the parentheses after the if statement, that's the conditional, and JavaScript will automatically try to coerce that to a true or to a Boolean and try to see if it's true. So all line 5 is saying is, hey, if array.isArray and we feed in the element, if that's true, then on line 6, you'll notice how we actually have a function called logs_array that we're feeding in the element. But logs_array is actually what the function that we're in is called right now, right, on line 1. And so this is just kind of getting further reinforcing this idea that if I could take a step back and describe at a high level what this function is trying to do. Actually, let me make sure that this is recording really quick. Cool. Sorry. Okay. All right. So all this function is really asking is to say, hey, now this time around, I'm gonna go through every single element in the array. If the element is a number, right? So if it's not an array, we're gonna go into the else statement on lines 8 through 10, right? So notice how lines 8 through 10 is actually doing exactly what we had been doing earlier, which was just to console log out the element. But now we've added this extra criteria to say, well, if something is not a number or if something is an array, then we're going to recursively call logs_array and we're going to pass in an array. And when we pass in an array, this logs_array function is going to execute again, right? And the way that the inner logs_array function is going to execute is going to be the same exact way that the outer logs_array function executes, except now we're kind of one level deep, right? On line 14, when I say one level deep, what I mean is if you think of the outer array as this array with two elements of 1 comma and then the array 2 comma 3, by going one level deep, all we're saying is, hey, let's go inside this outer parentheses And then when we encounter the element on line 5, that's the inner array of 2 comma 3, we're going to treat that array of 2 comma 3 like a brand new array, and we're going to call logs in array on that. And so if I was to look at our call stack, then how this will look is the first time I call logs in array of 1 comma 2, 1 comma array 2 comma 3. Well, when we go through the first element in that array, and sorry here, we forgot to put the brackets around the 1 and the 2 comma 3, but you can think of it, you can pretend like there's a bracket there. The first element we look at is number 1. So when we console log it out, we console log out 1. We then look at the second element, and it's an array, right? It's the array 2 comma 3. So at that point, when we go through our logs array function, we then reach line 6. And on line 6, all we're saying is, hey, let's call logs in array again, but now let's just feed in the element, the current element we're on, that is an array. And the current element that we're on is this array 2 comma 3. And so now when I actually try to do this, what the inner function is actually going to say is, it's going to say, great, let's go through this inner array element by element and try to figure out if there is an array or not. Sorry, if the element is an array or not. If it's an array, we're going to call logs in array one more time. If it's not an array, we're going to console log out the element. Notice how let's get rid of that. So notice how when I'm doing this here, so notice how when I'm trying to logs an array, this second element here, this array of 2 comma 3, notice how my outside logs an array function, that the initial logs an array that I called on line 14, that fed in the array of 1 comma and the element 2 comma 3, that's not finished yet, right? That's just taking a pause while I do this inner operation first, because remember, JavaScript runs synchronously, right? Which means that one line won't run until the line above it has finished. And so the reason why we're kind of adding this logs in array, this second logs in array function on our call stack, is because in order for the first logs in array function to run, the second one needs to run first, right? Like, we can't move past line 6 if we don't finish line 6. And so for the initial logs in array function, when we hit line 6 initially, that's going to say, great, we need to run logs in array of the array 2 comma 3. And the only reason we can move to the next line is once we finish the operation. And so right now you can think of us as almost taking a detour right now to finish this second function in our call stack first. And so when we do, all we're doing is we're going inside, we're checking the 2 and the 3. So when we first check the 2, we say, is 2 an array? No, it's not. It's not an array. So therefore, we go in and we go to line 9, we console log out the element. When we go to the 3, same exact deal. Is 3 an array? No, it's not. So therefore, we console log out the 3. And only at that point are we done with the kind of the inner logs and array function of the array 2 comma 3, right? And so once we've dealt with that, we've now also finished dealing with this entire array that we fed in on line 14. Because remember, once again, we took a look at the first element, which is just 1, right? It's just a number, so we logged it out. And then everything we had just been doing was trying to resolve how do we print out this array 2 comma 3. And now we're done with that as well. So now we reach the end of the array, and only then does logs an array of 1 comma the array 2 comma 3 finish. And at that point, we're done with the functions on this page. I'm really sorry if I said the word array way too many times, but like, recursion is very hard to explain verbally. This is one of the few lectures I really wish like we were in person for, so I could draw on the whiteboard and we kind of steps through it together. But for now, hopefully, if you just take a bit slower on your side and we run the code, it will become kind of clear what's happening here. And I guess just to wrap up this particular section here, the reason why this is really valuable to us, or the reason why we could not do this example in the same way that we did yesterday, was because if I try to do this with a for loop, theoretically, I have no idea how deeply nested my arrays could possibly be. Right? Here I have an array and I have an array within an array, so I'm nesting it 2 levels deep. So theoretically, if I wanted to use a for loop, I could do that. But what if I had an array in an array in an array in an array, right? And that goes, a dozen or a couple hundred or a couple thousand times. As far as JavaScript is concerned, that's totally valid. But you probably don't want to write a for loop that runs, a couple thousand times. Or sorry, you don't want to write a for loop that has to go a couple thousand levels deep, right? In this way, recursion becomes a perfect tool for us because recursion says, you know what, kind of like a while loop, right? Like recursion says, hey, I'm going to keep doing this for as long as I keep encountering this problem. And whenever this problem goes away, then I'll stop doing it. So we don't have to predetermine how many layers deep this has to go. Our function is set up so that it's configured to just keep going until it finishes the entire array. Or if it finds that one of the element is an array itself, then it will actually just open up another instance of another instance of logs in array and try to do logs in array based just on that inner element before it goes back and finishes out the outer function, right? So logs in array in this case is configured in a way so that we are able to actually not have to tell this function how many layers deep the array is. This function will just keep running until it reaches the end of the array. So it will just keep running as many times as it needs to. So if I also take a look at another example, very similar vein, right? If I had this concat else array, right? What this is doing is on line 2, we create a variable called final string, and initially we set it equal to an empty string. On line 3, we're iterating over an array that's being fed in. We start at 0, we end at the end of the array, and then for every element in the array, all we're doing is we're adding it to the final string. And when we're done, we return final string. So if I want to concat, an array with 3 letters, A, B, and C, all that does is it goes through the array A, B, and C, and it will add A to final string, and then on the next iteration of the for loop, it will add B to the final string, and on the third and final iteration, it will add C to the final string, and then we return final string, so we get back A, B, C, right? So this is a very traditional use of a for loop. Now, same problem that we saw before. What if now, rather than having an array of only having each letter as the element, well, we now have an array in which the elements could be either letters or they could be arrays of letters, right? If I had to use my old code, this would actually, I think it might even throw me an error, or it might give me some kind of weirdly formatted text, because what I'm trying to do is on the first iteration, I would go through, I would try to add A to the final string. That works. And then if I try to add the second element to a final string, I'm trying to add an array to a string, right? And so I think JavaScript at that point will either not behave as expected, or it will throw some kind of error at you. In this case, this is almost a mirror of the previous problem we did with logs in array, except now rather than just printing it out, we actually want to keep track of it. And so in the same vein as before, the concat else function is still set up so that we are fed an array on line 1. On line 3, we go through every element in the array. And on line 5, we check to see what the element is. If the element is an array, then what we're saying is, hey, why don't we run concat else, right, on just this inner element, on this element that's an array. Let me peel back the onion, if you will. Let me go one layer deep. However, if it's not an array, we're going to assume that it's a string, and at that point, all we got to do is add it to final string. So on line 8, we're saying if you're not an array, let's just add whatever you are to the final string. However, if you are an array, let's go to line 6. Let's recursively run concat else on this inner element and try to figure out what it is. So if we were to step through this again, when I run this initially, my final string is blank. After I go through the first element in the array, I get the A. So now my final string is A. And then if I go through the second element, I do trigger the array.isArray on line 5. And so I'm on line 6, right? And so final string is equal to the previous value of final string, which is 8, plus whatever concat else this inner element is going to give me. Well, the only way for me to figure that out is to run concat else with this inner array of B, C. So when I run concat else, B, C, I start off once again, because I'm running concat else in another instance of concat else, my initial final string is blank, right? Because I'm starting a brand new version of concat else that has nothing to do with the previous version. So my final string is initially blank. As I go through the array B, C, the first thing I encounter is the B, so I add to my final string. The next thing I encounter is a C, so I add it to my final string, and then I'm done, right? I reached the end of the array that's being fed. It only has 2 elements. I've done 2 operations. I'm now done, and at that point on line 11, I return final string. I return the string B comma C. So that's why I can now go back to whoever called me initially, which was the outside concat else function, which was waiting for me to figure out what the right. So on the previous on the last action here, on the bottom right hand corner of your screen, we were on the first line at least, we were waiting to figure out what concat else B comma C was before we could move on with that operation. We've now figured out it is B comma C, so we can replace that with B comma C, and now we do A plus or equal the string BC, which means let's just add BC to the end of A, and then we get back ABC, and ultimately that's what we get. That's what we return. Okay. Any questions on this problem? Does the walkthrough kind of make sense? I'm really sorry if it's confusing, but feel free to shake your head or let me know if it doesn't make sense. Everyone good? Thumbs up if you're good. Yes? Good? All right.
I have one question.
Go ahead.
If the original array had 2 more elements.
Yep. Sorry, I'm sorry. You cut off right there. Sorry, can you say that one more time?
So it has D in the original array.
Yep.
And then EF in a nested array.
Okay.
Does the BC one finishes and then it goes on to D, and then the D one finishes and then it goes on to the F, right?
Yep, exactly.
And then it all comes back to the original call.
Yep, exactly.
Okay.
Yeah, so basically everything happens in sequence and nothing after an operation can run until the operation finishes. So if I have an array with 4 elements, it has to process the first one first, finish with that before it moves on to the second element. And if any of those are arrays, in the code we have now is it will process those in arrays one at a time in sequence. Right? So if the second element is an array and the third element is a letter, it doesn't matter that the third element is easier to process. We will still have to finish the second element before we move on to the third element. Cool. All right. Okay. So this kind of brings me back to the earlier point I was making about why is this important or why are we doing this? Well, because when we talk about nested objects, so whether it be nested arrays, nested objects, or key value pairs, nested objects are very, very common, and they're also very confusing because sometimes, especially when we're dealing with nested values, you don't actually know how deep the nesting goes, right? If I give you an array, there's no cap to how deep, theoretically speaking, that array could be. And so whenever we're dealing with nested objects, if we're uncertain about how deep the nesting goes, then recursion becomes kind of one of the only tools to deal with this issue. So let's take a look at an example, right? So let's say we have okay, so let's just say we have this this function here called sumVals. On line 12, we'll see that initially all this that we're feeding the sumVals is an object. This object has 2 key value pairs. One key is A with a value of 10, and then one key value pair is B with a value of 20, right? And so if I look in sumVals, I feed in the object on line 3. On line 4, I create a sum equals and a sum value which starts at 0. On line 5, I go through every single key in the object that's being passed in. On line 6, I access the value in obj that's associated with that key, right? So that value equals obj index key. And then on line 7 is I add the value to the sum. And then once I do that, once I finish doing that for every single key value pair in the objects, because I am in a for and loop, I then return the sum on line 9, right? So if I could explain this in common English, all this function is currently provisioned to do is if you give me an object, I will go through every single value in your object and sum all of them up and give you the total at the end of it. All right, that's what this function is doing in concept. The for and loop just allows us to kind of write that, in a more programmatic manner. And in fact, if I do this, you'll see that when I start off, obj, because it has 2 objects, on line 4, I start with sum equals 0. On line 5, I say like key in OBJ. That means on the first iteration, let's just say the first key I see is A, then value is equal to OBJ index 8, which is 10, and then sum plus or equal 10, 0 plus or equal 10 is just 10. And then the next iteration of the for loop, I'm going to go to the key is B, and then for key B in OBJ, value is equal to object, and the value at key B, which is value equals 20, and then sum plus or equal 20 is equal to the previous value sum, which was 10, and then plus or equal 20 gives you 30. And then now that we've gone through all the key value pairs in OBJ, we then exit the for loop, and on line 9 we return the sum, which is 30. Okay. However, if I was to have an example of something like this now on line 15 or on line 14 there, where we have this heavily nested objects. Yes, we have some key value pairs where the key is a letter and the value is a number. But then we also had this monstrosity for B, right, where B is a key still, but the value for B is an object, and this object has another key, which has another key C, and the value of that is an object, and so on and so forth, unless we're going, in this case, like 4 or 5 object levels deep. So how do we add this? Assuming I still want to add up all the values in these objects, including the inner nested objects. Well, the solution is something that we've basically have been doing, in the past 2 examples, right? On line 2, we still start with our sum equals 0. On line 3, we're still going through every single key in OBJ. On line 4, we're still saying, hey, for every key, let's get the value that's associated with that key and store it in a variable called value. And now on line 5 is kind of where the recursion happens, right? On line 5, we're saying is if the type of this value is equal to the string object, basically if this value is an object, let's do line 6. If it's not an object, I'm going to assume it's a number and just add that value to the sum, right? So if it's not an object, I do line 8, which is sum plus or equal value. If it's not an object, we assume it's a number, and we're just going to add it on to the sum. However, if it is an object, I'm going to still add something to the sum, but what I'm going to add now is recursively, I call sum vals on this inner object. So if we were to go through our call stack, our stack trace one more time now, we have this call stack. This is what we start with. Our sum initially 0. As we go through the first key, which is A, the value is 1, and we have a sum of 1. So far, so good. When we go through our next key value pair, which is B, we say, oh, well, we can't just add an object. We have to make it into a number. So now we're saying 1 plus or equal sum vals, and we're doing the value of B, right? The value of B happens to be an object. So now we need to figure out what that value of B, what the sum vals of the value of B is before we move on. So that requires us to call a brand new instance of sum vals, right? And now we're feeding in just the value of B. Well, because we're calling a brand new version of sum vals, we still need to create a new initial sum of 0. And then we're saying, great, what's your value? Well, in order to figure out what the sum value of this object is, we need to figure out what the sum value of the first value is. And the first value is another object with a key called D. And so that requires us to now do a third instance of sum vals, except now we're passing in just the value from the original object. And basically, without ruining this, we kind of keep going. We do that one more time because we have 4 levels of nesting in this case. And finally, we get to this 4th level of sum val. So our 4th version of sum val basically says, hey, here's an object. It has 2 key value pairs, E and F, and the values are 2 and 3. Now, if we go through it, the first key, assuming we see it as E, the value of E is 2. So we can add that to our sum, which so far is good and clean. And then we go to the second key, which is F, and the value for F is 3. So we can add 3 to our 2, and we get back 5. And now we know what the sum vals of this object with E and F are. We can actually replace back whoever called it and just say it's 5. And so now if we go to the previous line, we're able to add 5 back to our previous sum, which is 0. And now this function is done, right? Because the object that was fed into this instance of sum vals only had 1 key value pair, and we just solved for that value. So now at this point, this function is going to return the 5, which takes us to the previous line. And once again, in this previous example, same exact idea. this object that was being fed into this version of SumVals only had one key value pair. The key was C. The value of this massive nested objects that we've already established is equal to 5. So here we can just return 5. And then finally, we can go back to our original function who had called the 5, add it back to our previous sum, which is 6. And now we're done. We say, great, we've gone through every single key value pair in not only this outer object, but every object nested within it. We got back a 6. And so now we can console log out 6. Cool. So very, very similar kind of approach to what we were doing before, except now rather than iterating through an array, we're iterating through an object. And just like in the previous examples, we have no idea how many levels deep this nesting is going to be for this object. And so therefore we have to use recursion here because, I can't pre-tell you how many levels of nesting there's going to be here. And that is pretty much it. Right? So conceptually, hopefully nothing here that you haven't seen before, except now we're just introducing a category of kind of a little bit harder problems. Because we're asking you to say, hey, before you could do it with a for loop and kind of do a loose translation to how that would look with recursion. Now we're entering a world in which you kind of have to use recursion. There is no way to do this without recursion. So yeah. Okay. So